The following video presents the diploma thesis, Surface Settlements Induced by Twin Metro Tunnels, Finite Element Analysis. The thesis was conducted by Anastασία Kocovίδου and Smaragda Leonidou in collaboration with Δημήτρης Pitilackis and Kωνσταντίνος Γεωργιάδης. The purpose of this thesis is to study and analyze the results of the opening of a twin metro tunnel in an urban area.
Plax 2D was used to simulate the ground stratigraphy, the two underground tunnels and the buildings above the excavation. Plax 2D is a powerful and user-friendly finite element software for 2D analysis. We studied and simulated 3 land sections in a really completed subway system, and great emphasis is placed on the surface elements of these sections. The parameters that are varied in the analysis of the sections are stratigraphy, the geotechnical soil characteristics, the depth of the underground aquifer, the depth of the tunnels, and the existence of the structures above the tunnels. The analysis aimed to investigate the ground surface stresses, in a second stage the tunnel and the overlying structures, in each case studying the results in terms of displacements. So, let's dive into the process of creating the simulation models accompanied by a brief illustration of the Plax 2D software.
In the first phase, the user enters the dimensions of the model and the model type. The soil values and parameters are inducted to create the borehole. In the second phase, the user creates the structures. In this phase, we created the twin tunnels, inserting the proper parameters such as the depth and the diameter. We also designed the buildings with 2 different simulation methods. In each method, we inserted the properties and material set of the building and TBM tunnel. The procedure is over after you generate a mesh which separates the whole model in smaller elements. In the third and final phase, which is called stage construction, the user creates different construction phases to match the real process. The whole procedure was completed in 6 stages, each of which adds a new feature to the construction. We started by simulating the buildings. Next step was the simulation of the excavation of the right and then the left tunnel. After each of the above phases, we added the contraction phase where we simulated the proper volume loss. The final phase is consolidation. Now, we are ready to press the calculation button. A report of the results emerges. In this thesis, we are interested in surface settlements. Plaxis allows the user to choose the phase he wants to see the ground displacements. Our team compared the results of 3 different phases: after the excavation of the first and the second tunnel, and after the consolidation phase. In the last phase, we can also see the settlements of the building, which appear in a triangular form with the largest values on the tunnel side.
Based on the results of this thesis, it is concluded that the settlements have a bell shape. Greater contribution of the final settlements has the second tunnel. The final phase of consolidation has slightly smaller settlements. There will not be any problem in the urban area due to the construction of twin metro tunnels. And last, for more realistic settling results, Plax 3D software can be used.